GM? GM. It's not GM, it's what? G. G. Okay, I'm trying to like make sure everyone is like paying attention. I know we are all very tired, but I mean, this is going to be the last session. I'm going to try to make it as brief as possible. Okay, first of all, introduction. First of all, thank you. Okay, my name is Jelilat Anofiu. I'm the Starknet Explorations Lead at Nethermind. And I'm going to be talking about Starknet transaction simulation and execution analysis. I want us to see this like as an extension to what Dave just like spoke about. He spoke about tests, and I see simulation as like an extension of what he currently spoke about. Next slide, please. Okay. So yeah, wow. Okay, I feel like I changed some things here and this looks old. Anyways, so we are going to be talking about transactions on Starknet, transaction simulation and execution analysis. And I'm also going to be talking about some use cases of transaction simulation. I was going to give a demo, but I mean, due to the technical glitch, we can't have that demo right now. And probably we skip on to Q&A. Okay, next slide, please. Next slide. Okay, transactions on Starknet. I wanted to like ask, has anyone here performed any transaction on Starknet before? Transactions on Starknet. Transactions on the blockchain. Transaction from your bank account to another bank account. Has anyone here ever like sent money by mistake to someone else's account? By mistake. No mistake. Okay. I mean, I'm just trying to highlight how, okay, from the people that have mistakenly sent money from their bank account to another bank account, have they been able to recover it? Is there anyone here that has been able to recover their money back? Okay, have you mistakenly sent crypto from one account to another? Has anyone been able to recover it back? Okay, I just wanted to highlight how transactions on the blockchain is like, I mean, it's not reversible. I mean, or maybe if you know the person you mistakenly sent money to and they are a very nice person, and they feel like, oh, I can give you your money back, probably you'll be lucky. But when you are transacting on the blockchain, it is very, I just wanted to highlight the importance of like transparency, the importance of knowing what you're sending before you're sending it, right? So you can mistakenly send money to someone else and on your normal bank account, and you could go everything can go well at the end of the day. But with blockchain, well, the probability of that happening is very slim. And I wanted to like first review like transactions on Starknet. This is like a screenshot. I don't know if you can see very clearly of one of the wallets on Starknet. And this is a transaction I tried to make on MySwap. I wanted to swap ETH with Stark. And here I can see approved spending limit. It's like showing me like a breakdown of like the transaction, what I'm trying to do. I'm first going to approve the contract to spend my money. Then I'm going to swap the money for like ETH for Stark, right? Next slide, please. Okay. When you click on like the breakdown of the transaction, I guess something like this. Has anybody here used Agent's wallets or any Starknet wallets? Right. Do you know what this call data is? Does anyone know what this is? Nobody knows what it is. Sorry? Okay. I don't think, maybe there's someone that knows it and I'm just not getting the answer I want. But this is like a breakdown of like what you are trying to do on the blockchain. Like, okay, I think this was for the approval. And this is telling me, I think the first one is the contract address I am approving to spend my money. And the second is the amount I am approving to spend, right? Looking at that, can you like decode the information from looking at that? No. Okay. Thank you. Let's move on. We are still going to come back to that, by the way. Next, okay. Now, this is from a transaction. This is also a screenshot from Agents. But this transaction is going to fail. It's telling me amount cannot be zero. I'm trying to, it's actually a random smart contract written on Cairo, and it is taking an input to increase balance. If you try to increase the balance to zero, you get this error. And have anybody ever gotten this random error trying to do something on Starknet before? Something like this. You have gotten something like this. Do you understand all this error, got an exception, blah, 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 that is happening here? Do you understand it? You don't understand it. Okay, thank you. Next slide, please. Okay, yeah, this is where we now come to the main topic of the day, transaction simulation. Transaction simulation, also known as dry run, is the process of predicting the outcome of a transaction before sending it on-chain, right? Okay, you can think of transaction simulation in blockchain network as a developer sandbox where you can test your code. Do we have any developers here? Have you ever pushed to production before? Anyone? What's the difference between a sandbox and a live environment? Do you want to? One is for real life. One is real life. When you have 1 million ETH, okay, just like testnet and your mainnet, you can have 1,000 Cipolla hits, and on your main account you have 0 ETH. That's the difference. You can't spend the artificial 1 million you have on that your testnet, unfortunately. And that's the difference between a developer. So we can see transaction simulation as we are trying to send a transaction, as I pointed out earlier. When you send money on the blockchain mistakenly, or you perform a transaction mistakenly that is going to drain your accounts on the blockchain, you can't reverse it back, right? So that is why we need a sandbox, a transaction simulation, to let you know that, okay, this is what is going to happen when you try to perform this transaction. Before you approve this transaction, it's going to tell you a breakdown of everything that is going to happen, give you a dry run of everything that is going to happen before it happens. Next slide, please. So yeah, I said we are still coming back to this, right? This is from the first screenshot I shared earlier that is showing you approved spending limits, swap, and everything that is going to happen to your transaction. If I approve the transaction. Next slide, please. Now, this is a simulation of the same transaction. This, I'm not sending it on-chain. I'm just simulating it, that this is what's going to happen. From the last slide, you get this approval, and you get the swap transaction, right? What you don't know that is happening on the background, a lot of this, is that there's a transfer function being called somewhere. You don't know about it. That doesn't show you the details. There's a transfer from function being called somewhere that you don't know. But what a simulation will do is it's going to show you this is going to happen, right? So a simulation goes into like the intricate details and shows you every step of the way. If you are calling 1 million smart contracts inside your smart contract, a simulation is going to point to each of those transactions that is going to happen, each of those smart contracts you are calling, each function you are calling is going to break every single thing down for you. That's what a simulation is going to do, right? So for a user that is saying that, oh, you don't know that there's a transfer happening somewhere. You know, there's a swap. Maybe you don't know that swap means I'm going to transfer something, I'm going to decreasing a balance or increasing a balance. But the point is that a simulation is going to break everything down for you. Next slide, please. Sorry, can you go to the previous slide? Okay, yeah, this is, let me break this down. This, if you are familiar with Cairo or smart contracts accounts on Starknet, you know, for Ethereum, it is EOA, externally owned accounts, but for Starknet, they are smart contract accounts, right? So each of these accounts have an execute function, right? So this is the function that is being called, your execute function. If you can notice, there's a slight padding here. So you can see this is a child. These two, they are children of this. So this function is calling another function. It's calling an approved function somewhere else. It is not in that smart contract. It's calling it from somewhere else. It's also calling a swap function from somewhere else. You can see that these two, if you can check the padding, they are children of this swap function as well. So this swap function is calling a transfer function even somewhere else. As I said, if there's like a million child tree, like a tree like that, a simulation is going to show you every single tree, everything that is going on in that transaction. We good? Next slide, please. So now, let's go back to the first, if you remember this slide I showed earlier. So this, I was asking like, what does this mean? I feel like a lot of people don't know what that means, and that is the call data. This doesn't explain anything to the user. They don't know what this is. Next slide, please. Now, this is, I can't show everything because, there's a limit to what I can show here. But if you remember, there's more details there. So when I click on more details, it shows everything you were seeing there that you don't understand those numbers. The simulation has broken it down. Those are inputs of everything. These are the inputs, and this is the output that you expect from calling that transaction. So you're saying 2 plus 2 is going to be 4. That's what it's telling you. This, if you do this, this is what's going to happen. This is what's going to return. And this is what you are inputting, and this is what the output would be. All of this breakdown, it is not sent on chain. It is simulating it for me. It's telling me this is what is going to happen if you do this, right? So it is breaking everything down every step of the way. No matter how deep the stack can be, it's going to break it down. That's what the simulation is going to do. Next slide, please. Okay, we are back here. We are back to this error. This is just a string of error. The only thing I feel like I can get here is amount cannot be 0. Everything else, I don't even know what's happening here. Right? I don't know what's happening here. What is this error about? And I really wish, I wanted to show a demo for this. How, for context, all the screenshots of the simulation I've been showing, they are Nethermind, the Nethermind explorations team. We are currently working on a transaction simulator. And the transaction simulator is going to make it very easy for you to predict any outcome of any transaction, right? And it is also going to tell you if there's any error in the simulation happen, it's going to point it back to the exact line of code where that error came from. So you can write any Cairo code, no matter how long it is. It's going to tell you this error came from so line of code in your simulation, right? That's what we are trying to give you here. Oh, there's supposed to be a slide. This is not updated, unfortunately. I added something, but it probably didn't get added. Next slide is fine. So, there's a slide missing, but we can move on. But now let's move on to why is previous slide, please. Why is transaction simulation important? And when I first started, I said I see this as an extension of the last speaker talking about tests, right? Tests are fine, sandbox is fine, but like when you come into you see somebody, you say, I'm writing this code, it's running one on my local host. But when I publish it to the web, it's saying, there's error. Where is this error coming from, right? So you can write 1 million tests. They are fine, they are very important, but when they come online, because there are external factors that are affecting them, you are calling one certain contract somewhere. Someone with a use case, like a scenario that you have not even thought about, is using your contract a certain way, right? And you don't even think about this, right? That is why simulation is very, very important, right? Beyond just writing tests. Write tests, definitely, but after the test, make sure you simulate this against a live environment. How it's going to behave in a live environment is very, very different from what your test is going to give you, right? So, like, why is transaction simulation important? UX and security. UX here, user experience here, is telling the user everything that is going to happen, right? And there's a security part that tells you what you are signing is not, you're not supposed to be signing this. If you sign this thing, it's going to drain your wallet. Don't sign it. That's what a simulation will tell you, right? So that is why the importance is like security part of like the importance of transaction simulation. Now, gas optimization. Another thing about transaction simulation, which unfortunately I didn't remember to add there, is going to tell you how much gas this is going to consume. Everything, like, what's the maximum, like how much gas is going to consume, like, so you can optimize your function. Because one of the issues with Ethereum is that, I mean, you have to pay for gas, it's too expensive, gas is too expensive. And you see people trying to optimize their code such that it uses as less gas as possible so that it can be cheap for your users, right? So what simulation is going to tell you, so you can test like, okay, maybe if I tweak this function this way, it's going to consume less gas, right? And you can't keep deploying your function to production all the time because you want to test gas, right? So you can simulate all of this and tweak this function. As a developer, simulation helps with gas optimization. It also helps with debugging. Earlier, I talked about tracing your error to the exact line of code where it occurred. No matter how deep the stack is, it's going to trace the error back to the exact line of code. That's what transaction simulator is. And exploit mitigation. I mean, I talked about what you see in a test environment and what you see in a live environment. So as a security researcher, you should definitely know about simulation. If you are very familiar with security, does anybody know about Tenderly here? Ever heard of Tenderly? Tenderly, yeah, nice. What does Tenderly does? Anyone? Simulation. They have so many things, but simulation is one of like what I want to touch on here, right? So they allow a lot of security researchers use Tenderly so that they can, if there is an exploit, or they can create exploit type scenarios on smart contracts, right? Yeah, so they can create those scenarios and they can maybe manage the exploit and tell you, okay, oh, you need to modify your code somehow to fix this issue that could happen. So what we are doing now is just creating that same Tenderly simulation that you get on Ethereum, so you can also do the same on Starknet, right? So next, I think that's it. That's majorly it. I would have loved to do a demo, but unfortunately, we couldn't do a demo. And question and answers, I don't want to take too much of our time. I think that's good. Oh yes. For this, I want to like use this, I don't know, this group as like a test group. I mean, it's something we are releasing. So if you would like to be one of the people that first people that will test, you can send me a DM on Twitter, Telegram, at Jelilat. Let me just write it down. Free for now. Yeah, Tenderly is paid. Yeah. Both. Both. Okay, now. No, not exactly. So yeah, this is where, as a developer, I feel like the developers are the main target markets, right? So you should use our simulation. The plan is to release an API that makes a lot of things very easy. So when you use our simulation API, you can showcase it to your users to make it very simple. And one of the discussions we are having around this is AI. Interesting how you can give AI like a breakdown on all of this. And it's going to change it into a user-friendly type interpretation that will make it easy for users to understand, right? So that's one of the things that we are currently exploring.